Now I understand I have given you this question from photo as homework. You are interested to know the angle between alpha and beta. How do you get the angle between alpha and beta? Listen to this. Any electric line of force generated between these two will not be able to cut here or here. It will have to go into minus q. You cannot have an electric line of force which either comes out this way or this way, nor will it come till here and evaporate. If it is generated from here, it should be going into this. All the lines of force from here should be going into this, because this line is going into, this line is going into. Agreed? So the total flux generated between this angle should be equal to the total flux entering in this angle. Flux generated at alpha should be equal to flux entering into beta. What will be the flux generated from here? 4 pi solid angle will have q1 by epsilon naught. This solid angle, this is 2 pi into 1 minus cos alpha, will have q1 by 4 pi epsilon naught into 2 pi into 1 minus cos alpha. This is q1 by 2 epsilon naught 2 sin square alpha by 2. q1 by epsilon naught sin square alpha by 2. Similarly, for 4 pi the flux entering into is q2 by epsilon naught. For 2 pi into 1 minus cos beta, the flux entering will be q2 by 4 pi epsilon naught into 2 pi into 2 sin square beta by 2. This will be q2 by epsilon naught sin square beta by. So equate this to this, you will get the relation between alpha and beta.
So can you please explain the concept again, sir?
Total flux generated in between these two lines should be equal to the flux entering into these two lines. Any line generated in between this cannot cut through this or cut through this and go out. So it should be going into this. So you calculated the total flux generated between these two lines, equated it to the total flux entering between these two lines. How did you calculate this flux? For this solid angle, this is the flux is what was told you. For this solid angle, how will I get this? 2 pi into 1 minus cos alpha. For this solid angle, the flux will be this. You did the same thing on the right hand side and equated both the flux.
Okay, thank you. Sir, in the question, if it were positive charges, we wouldn't have been able to do this, no, sir?
Yes, because positive charge ke wajah se he cannot give you this diagram. If this is positive charge, this will be wrong. The line coming from here will not go into this. Somewhere here the field will be 0. So the line will be like this. Dadar center, switch on the mic.
Yes, sir.
Hi. Okay, now that you switch on the mic, the noise has become 0 level. If not, your noise is quite high in the room. All of you say hi once.
Hi, sir. Hi.
Sir,
Yeah.
so how would we solve for that case when both are positive?
How will they ask you the question? The question don't exist. When both are positive, lines will be going out this way. Line will not go from positive to positive. A line will go from positive to negative only. They cannot ask that question. We will introduce this concept of shielding. We'll introduce this concept of shielding. But before we do that, we will have to justify the THANE, switch on the mic. THANE, switch on the mic.
Yes, sir.
Are you able to hear me?
Yes, sir.
Please make sure that the noise level is low. Please maintain silence. Right. Listen. Before we deal with this, two applications of Gauss law here. This is capital R. If I am interested to know the field outside, I will assume a Gaussian surface like this. I will assume a Gaussian surface like this. This Gaussian surface will have E and ds this way. You are interested to know the field at a distance of small r. So you assumed a Gaussian surface like this. This will be the Gaussian surface. Closed integral E dot ds will be equal to q by epsilon naught. E integral ds cos 0 will be q by epsilon naught. E into 4 pi small r square is equal to q by epsilon naught. E is 1 by 4 pi epsilon naught q by r square. 1 by 4 pi epsilon naught q by r square. What if I take the same shell and tell you the field inside? I take the same shell and tell you the field inside. I'll assume this to be the Gaussian surface. Gaussian surface. Now here, inside the Gaussian surface there is no charge. Inside the Gaussian surface there is no charge. So closed integral E dot ds will be equal to 0. But remember, this doesn't mean that the field will always be 0. If integral E dot ds is 0, there are 4 options. Field can be 0, second option. ds can be 0, third option. E is perpendicular to ds. There is a fourth option. If I have a uniform field like this and a cube like this, then the flux will be 0. Flux entering will be equal to the flux going out. Rather, I will put it this way. If I have a uniform field and a cube, the total flux here will be negative, total flux here will be positive, and they will be equal and opposite. So among the 4 options, I assumed a Gaussian surface, so I eliminate this area to be 0. I know the area is not 0. Right? I took E perpendicular to ds, not possible. This will be eliminated because outside the field is radially outwards. Inside, for this to be ds, the field should be tangential. अगर अंदर tangential field है, so it should be circular. Closed circular loop is not permitted for my field. Hence this option is eliminated. Uniform field है ही नहीं because outside field is radial. Inside जाकर uniform थोड़ी बनेगा. If अगर अंदर uniform field ऐसा आना है, तो outside field cannot be this. Why? Because the lines when they go inside they will intersect. So this option is eliminated, this option is eliminated, this option is eliminated. Leftover will be field will be equal to 0. Closed integral E dot ds is 0 inside this particular Gaussian surface because inside there is no charge. But not always will field be 0 if this is 0. The other 3 options should be looked out for in this situation. If it is a uniform field and a cubical Gaussian surface placed, then you will have integral E dot ds to be 0. Right? Doesn't mean that the field is 0. Clear? You are confident in dealing with these options now because you already know that the field inside the shell is
0.
Quick.
Sir, is there any case in which ds can be 0?
Can you go one bench back? I am unable to see you. The first bench is not visible for me.
Sir, can you give a case in which the ds is 0?
ds you are considering a surface. Where from will you get ds 0? If you consider a surface, then ds will not be 0 for sure.
Okay, sir.
Sir, can you explain it C part perpendicular?
Which one?
C
E and ds should be perpendicular. If an electric line of force is like this, then I will have tangential field here, and this will be ds, this will be the field. This will be the field, this will be ds. E dot ds will be perpendicular. But I know electric lines of force cannot be tangential. Rather, electrostatic lines of force cannot be tangential. Circular. Closed loops not permitted. Hence I eliminated that option.
Thank you, sir.
Thane, switch on the mic again. Thane, switch on the mic.
Yes, sir.
Say hi.
Hi.
Good. Right. Maximum noisy class yours is. When you switch on the mic, the noise goes down to 0. Right. Listen. Now the other is solid, non-conducting. You have dealt with this. Solid, non-conducting me. If I want to use Gauss law here, this is capital R. Solid, non-conducting me. Outside external point, now I assume a Gaussian surface. Outside external point, now I assume a Gaussian surface. Closed integral E dot ds will be q by epsilon naught. You get the answer. Inside, how do you get? I assume a Gaussian surface like this. This is small r. Closed integral E dot ds will be equal to q by epsilon naught. Closed integral E dot ds will be equal to q by epsilon naught. Right? E integral ds cos 0 is rho into 4 by 3 pi r cube by epsilon naught. Rho into 4 by 3 pi r cube by epsilon naught. That will be the charge enclosed inside. Now E into 4 pi r square is equal to rho into 4 by 3 pi r cube by epsilon naught. Right? This pi will go, this will go. E is equal to 4 will go. Rho r by 3 epsilon naught. E is equal to rho r by 3 epsilon naught. This is something that we are aware of. Right? You told me previously that the field inside a solid sphere will be 1 by 4 pi epsilon naught q small r by r cube. This is what you told me. It is as good as this. Irido writes it this way. He is more comfortable with that. How did he do it? 4 pi epsilon naught rho into 4 by 3 pi capital R cube R by R cube. This will turn out to be rho R by 3 epsilon naught. This is what we have told you previously. It is as good as this. Rho R by 3 epsilon naught. Rho is the charge density. Inside a cavity, what will be the field? That R will be the distance between the two centers of the sphere. This is O to O dash. This is R. Right? Now here if I want the field, I will take this to be X. And if I fall this is to be Y. Right? Field at the point P is rho x by 3 epsilon naught. Sorry, due to the complete sphere it will be rho y minus rho x by 3 epsilon naught. Because of the complete sphere it is rho y, and because of the hollow sphere it will be rho x by 3 epsilon naught. This turns out to be rho r by 3 epsilon naught, where r has a different meaning here. R is not the distance of that point from the center. R is the distance between the two centers of the two spheres. Right? Two centers of the two spheres. Quick. You are aware of this formula. We derived it using Gauss law. Here one logic can be told. Please pay attention here. By chance if O and O dash are at the same point, R will become 0. Field will become 0. That's what we told you. Inside a shell, the field will be 0. If O and O dash are at the same point, then you are dealing with a concentric spherical shell. Inside the shell, the field will be 0. This is what we are telling you. In the first part of shielding, we have just justified Gauss law with examples that we know. You were aware of this result previously, you were aware of this result previously, you were aware of this result previously. You are just justifying Gauss law that it can be done this way, in a much shorter way. Now here comes the concept of shielding in the same subset. Understand this logic. For a metal, if I have a uniform field here, I have positive charge in this particular direction. Now place a metallic body in between. Place a metallic body in between. Please pay attention to this concept. It is the most important concept in electrostatics. Now because this is a metal, there will be induced a negative charge on this side and induced positive charge on this side. The induced charge will generate a field in the opposite direction. So net field inside will become 0. This is what happens. To make the diagram a bit clear to the kids, some textbooks draw it this way. They will draw positive, negative, and you have a field here, negative. Now you have positive charge here, it will be positive to negative. So net total field inside has become 0. Now there are two misconceptions which originate from the way we have introduced this concept. First misconcept, people came up with theories that the external field will not enter into the metal. Now this is the most meaningless thing. Resnick doesn't like that. He says the external field, if you ask me the value of external field inside the metal, it is E. Value of external field inside the metal does exist. The induced charges will nullify the field inside. Right? So don't tell me that external field did not enter inside the metal. It does enter inside the metal but gets cancelled out. First misconception. Is it clear to all? External field does exist inside the metal. Net field is 0. Other than this, there is one more popular misconcept which gets originated here. The misconcept is, the way we have introduced the concept, you will feel because there is induced charge, the field became 0 inside the metal. Because there is induced charge, the field became 0. But it is the vice versa. Because the field should become 0, there will be induced charge. Because field should become 0, because the field must be 0 inside a metal. Induction takes place. That means, what are you clarifying? We are clarifying that the field becoming 0 inside a metal is a priority. How is that being achieved? By the induced charges on the plates. If the induction doesn't take place, the question doesn't arise. If the field is non-zero, induction will take place. But by any chance, externally, you have influenced the system and made the field already 0 inside the metal, then induction will not take place. Induction is a byproduct of this priority. Induction is a byproduct of this priority. Priority is field must be 0. Why should the field be 0 inside the metal? In the third lecture from now, we will calculate the potential energy stored in an electrostatic field. This will be derived in the third lecture from now. Half epsilon naught E square into the volume. Energy density will be this. Are you trying to tell me wherever I have a field, Wherever I have a field, you will have potential energy. Yes. Nature prefers least potential energy state. Now listen, I repeat the two misconceptions. Firstly, the way we introduce the concept, do not be under the impression that the external field doesn't enter into the metal. It will enter into the metal. It will enter into the metal, but it gets cancelled out by the induced charges. Now don't believe that induction is the root cause for the field to become zero. It is a vice versa. Priority is field must be zero. Induction is a byproduct of it. Induction becomes the means by which you will attain this particular point. Why do you think nature prefers to make the field zero? We will calculate in days to come that potential energy will be half epsilon naught E square. Nature will always try to make the potential energy zero. Can you give us examples which we know? Yes. If I have Q and minus Q, what will nature do? It will attract both of them, merge into both and make the field here zero. If I have Q and Q, nature will repel both the charges to such an extent that the field here will become zero. Keep two charges here in open space, they will be repelled to such an extent that the field here becomes zero. Unlike charges attract and like charges repel to make sure that the field is decreasing in that vicinity. So nature always attempts to make the field zero, minimum, because nature prefers least potential energy state. First point that we try to justify is field becomes zero inside a metal. How will it achieve it? Suppose I take a hollow metal or solid metal, hollow metallic sphere or a solid metallic sphere. In either of the two cases, you told me the field inside will be zero. You have derived this in gravitation, you have derived this in electrostatics, and you have done it using Gauss law. But let us understand what is the mechanism that is happening here. The charge is uniformly distributed. If the charge is uniformly distributed, look out for this logic. If the charge is uniformly distributed, I will consider a point here because of ds1 and the point here because of ds2. The two small elements that you are considering as ds1 and ds2 will be very small, right? So that I can use the concept of point charges. Now at this point, field because of this point charge is k dq1 by r1 square. This distance will be taken as r1, this distance will be taken as r2. Distance means I should draw a line from here to the center, right? Now what happens is field because of this at this particular point is dq2 by r2 square. dq1 will be sigma ds1 by r1 square, sigma ds2 by r2 square, right? Now the vertically opposite solid angles will be equal. For me to get that to be the vertically opposite, I cannot say ds1 by r1 square is the solid angle. I can tell you ds1 cos theta by r1 square will be the solid angle. Similarly, this will be cos theta. ds2 cos theta by r2 square will be the solid angle. Both the solid angles are equal. If both the solid angles are equal, these both will be equal. Hence the field inside will become zero. I repeat the logic, please pay attention. I take this to be ds1 and I take this to be ds2. This area ds1 by r1 square, k dq1 by r1 square will be the field here, k dq2 by r2 square will be the field here, dq1 will be sigma ds1, but remember ds1 by r1 square will not be the solid angle here, because when you introduce the solid angle you told me this is r and this is ds. R and ds should be perpendicular. So ds1 cos theta by r1 square. I can multiply cos theta on both sides. ds1 cos theta by r1 square is the solid angle here. ds2 cos theta by r2 square is the solid angle here. These both quantities are equal, so both the fields will be equal. Right? Hence the field inside is 0. You did not use the concept of a metal here. You used the concept of uniform charge distribution. You used the concept of uniform charge distribution. HCB is asking you in a reasoning question, if instead of a metal, I have a rubber spherical balloon and the charge is uniformly distributed, will the field inside be 0? Yes. Whenever the charge is uniformly distributed, the field inside will be 0. What is the difference between a metal and a non-metal? For a metal, if I give charge, it will naturally distribute uniformly all throughout. Non-metal, you will have to distribute it uniformly, only then the field will be 0. Non-metal cannot distribute the charge on its own to make the field 0. Metal can distribute charge on its own to make the field inside 0. But if ever this is uniformly distributed on a spherical surface, field inside will be 0. Is this clear? Quick.
Sir, can you repeat that statement in the last example?
Take it down and dictate that. Take it down and dictate that. Take this down and dictate this.
Sir,
Yeah.
so that curved surface DS1 and R1 line R1 are they perpendicular to each other? So that curved surface.
This is DS1. This dotted surface is DS1 cos theta. R1 is the distance from here till here.
So no, so my doubt was about that. How did you take that DS1 cos theta?
This is DS1. This is R1. This will be DS1 cos theta. This area will be DS1 cos theta. This area will be DS2 cos theta.
Okay, sir.
And both the sides thetas will be the same. Remember that. If you draw a chord like this, tangent drawn here, tangent drawn here, this angle will be equal to this angle because this is the radius. Now these two angles will be equal. If those two angles are equal, these two angles will be equal. Hence I multiplied with cos theta there as well as cos theta here. Theta is the same on both sides. Write down, note.
So Sir,
Yeah.
sir, since charge is quantized, how can you justify saying dq?
Why? dq? What is the problem for that?
Sir, because it is quantized, right?
Yeah. Sand particles, each sand particle is quantized. If I want to calculate the weight of sand, I can consider a small element d mu, dq. But it's
So
quantized.
but it won't increase continuously, right?
But that is the discretion between. If sand is falling on the ground, how do you calculate the force? Sand is quantized, you will have every tiny particle, right? But you take an element dq.
Yes, sir. So because it is very small, that's why you can assume it to be almost
Naturally.
right?
Naturally.
Okay.
Note. If the charge distribution is spherical, and uniform, the field anywhere inside will be 0. field anywhere inside will be 0. Next point. If the sphere is a metal, if the sphere is a metal, if the sphere is a metal, then the charge will distribute, uniformly on its own. Charge will distribute uniformly on its own. The next you don't need to write. This is quite obviously implied for the next, that if it is non-metal, on its own it will not distribute. You will have to distribute it uniformly. Only then the field will become 0. Is the logic clear? Can I rub the board?
Yes, sir.
Sir, don't delay the right part. So please wait for some one.
Sir, in the last example you said that as the field is becoming 0, so induction takes place. Sir, I didn't understand.
Field becoming 0 is a priority. Induction takes place to make the field 0. Write a note. Note. Induction takes place to make the field 0. Induction takes place to make the field 0. Listen. Now we speak about a spherical cavity. Spherical cavity. I have a charge q inside the spherical cavity of inner radius and outer radius. This is a metal. Now, what did you tell me? Induction will take place in such a way to make the field 0. That means this Q will produce some field inside the metal. So minus Q on the neutral metal will be pulled in and plus Q will be pushed out to make the field 0 inside the metal. This minus Q will be uniformly distributed like this. Plus Q will be uniformly distributed like this on the outer surface to make the field 0. The electric lines of force will be like this. Plus Q say minus Q, there will be electric lines of force. From a neutral metal, minus Q is pulled in and plus Q is pushed out. So Q and minus Q will give me 0 metal inside, 0 field inside. From a neutral metal, minus Q comes in and the minus Q will be distributed in such a way so that Q and minus Q will give me 0 inside the metal. For any external point, whole of the charge appears to be at the center. So this minus Q and Q together will give me 0. This plus Q will be uniformly distributed, only then it can give me 0 inside the metal. Now reading the names of your classmates is so very essential for you. Right, right. अपना साइन करके बगल में दे दो यार, जल्दी करो. Minus Q is pulled onto the inner side of the metal, and we have learnt that for any external point, whole of the charge appears to be concentrated at the center. So this minus Q will appear to be concentrated here. So these both will cancel out here in the metal, not only in the metal, even outside. Q and minus Q will cancel out, not just in the metal, even here. Now the external charge must be uniformly distributed, only then it can give me a 0 inside the metal. Not only inside the metal, external charge will give me 0 even inside cavity. Right? In principle, if I disturb this particular charge, inside the metal, I kept this Q here. Now the negative charge on the inner side of this particular metal will redistribute, but the external positive charge will remain the same. Why? Because the negative charge should redistribute, only then it can cancel out the effect of this Q here. I should get 0 field because of Q and minus Q. But the external charge will remain uniform. Why will the external charge remain uniform? Only if it remains uniform, it can give me 0 inside the metal. We have seen the conditions for uniformity. Only if it remains uniform, the field inside the metal will become 0. If I disturb Q from the center, the negative charge on the inner side will redistribute such that it should cancel out the effect of Q for any external point. So minus Q will get redistributed. While redistributing, remember one thing. These negative charges will redistribute such that the electric lines of force intercept the surface perpendicularly. They should intercept the surface perpendicular because the metal is an equipotential surface. So the line should intercept the surface perpendicularly. But the negative charge redistributes so that the charge Q and minus Q together will give me the field 0 everywhere outside. So this 0 you are telling me is the field due to all charges inside the cavity. This field is due to all the charges, all the external charges. So the concept of shielding goes this way. All internal charges put together will give me 0 field everywhere outside. All external charges put together will give me 0 field everywhere inside. All internal charges inside the cavity put together will give me 0 field everywhere outside. Not just here, even here. All external charges put together will give us 0 field everywhere inside. Right? We will go into the depth of this analysis. Take this down, I will dictate the statement.
Sir, could you please repeat the left side part?
Whole of that will be understood. Take it down. Take it down, everything will be understood. Come to this condition. This charge must be uniform. That condition will come later.
In first case, you have put a positive charge inside the sphere, right?
Yes. What is kept here is plus Q. Only then minus Q is pulled in. If I keep minus Q, plus Q will be pulled in. Please write down. All internal charges of the cavity put together. All internal charges of the cavity put together give a 0 field everywhere outside. All internal charges of a cavity put together give 0 field everywhere outside. Quite obviously you understand that I am speaking about a cavity in a metal. This is a metal. Nothing of what I am explaining will be applicable if it is not a metal. Right? By default everything comes into the subset of a metal. Right? Full stop. Next statement. All external charges put together external charges put together will give a zero field everywhere inside. Will give a zero field everywhere inside. Will give a zero field everywhere inside. Everywhere inside means what does that mean? Both inside the cavity as well as the metal. Right? Now let us dig into the details of this. I have Q here, I have minus Q here, Q here. This is a neutral metal. This was originally a neutral metal. Now you kept charge Q at the center, so it will pull minus Q inside so that these both will give me 0 here. So let me take this radius to be small r, this radius to be capital R. There is a point 1 at a distance of x. I took a point 1 at a distance of x. Now what will be the field? What will be the field at point 1 due to Q at center? Because of this Q, what will be the field here? This will be KQ by x square. It's a point charge. Field at 1 due to minus Q on the inner surface. Can somebody tell me the answer? Because of this minus Q, what will be the field at 1?
Minus KQ by R minus
0. 0. The charge will be uniformly distributed. If a spherical charge distribution is uniform, the field inside will be 0. Now field at 1 due to Q on outer surface. Louder. 0, because that will remain uniformly distributed. Rather, vice versa. Because the field should become 0, this charge will be uniformly distributed on the surface. Now come to the second point. I am selecting a point 2 at a distance of y from the center. Point 2 is inside the metal. Point 2 is inside the metal. Now field at 2 due to Q at center. The point 2 is inside the metal. 1 second. Wait, CHEMBUR, switch on the mic. CHEMBUR, switch on the mic. The first bench, both are lost in it. First bench, blue t-shirt boy, center boy. Tell me the value here. Hi. Blue t-shirt boy, kindly look at the board. There is a question on the board. Please answer that. Quiet. Louder. Stand up. What's your name? Louder. Aniket. I'll give you one hint. The field is not 0. Now tell me the answer. Look back to your notes and read out the last statement that you wrote before this. Louder. स्टेटमेंट पढ़ लो एक बार जोर से, मुझे सुनना है. अब अंग्रेजी सिखाना पड़ेगा ना यार आपको. नोट्स है कि नहीं आपके पास? लिखा ही नहीं, अब क्या समझ में आएगा यार. काहे का पढ़ाई चल रहा है यार आपका. Listen, sir, listen. Have you written or not? Don't waste the time of the class. लिखा है आपने? Then read it out loud now यार. स्टेटमेंट KQ by x square है. स्टेटमेंट पढ़ लो ना यार एक बार जोर से. सुनना चाहता हूँ मैं.
all
Oh God.
internal charges of cavity put together.
All internal charges of the cavity put together. Please read that line.
All internal charges of cavity put together gives zero field everywhere outside.
Perfect. What does that mean? All Q and minus Q will come in the internal charges. Both put together will give me zero field here. Agreed?
Yes, sir.
Now, what will Q give me? KQ by Y square. Y is the distance here. This is what Halliday-Resnick is telling you. Some textbooks in the start tell you the field lines don't enter inside a metal. Wrong. Because of Q they entered inside the metal. But they get cancelled out by minus Q. Sit down. Why are you standing?
Thank you, sir.
Right. Listen. Q will produce a field inside the metal. Don't tell me field lines don't enter into a metal. They enter, but they get. Now, field at 2 due to minus Q on the inner surface.
Sir,
Minus KQ by Y square. Sum of both should be 0. Who is that? Tell me.
Sir, THANE. Sir, you said that field doesn't enter. Sir, it is fundamentally correct statement. Sir, because if it gets cancelled, then our null point is created. Because the null point will not enter the
Then please answer my first question.
Correct, sir.
Field at 2 due to Q at the center.
Sir, due to Q it will be KQ by R square. But
वही तो बोल रहा हूँ ना यार. Don't tell me external field doesn't enter inside. It can, but it gets cancelled out. There is a difference in the interpretation of the two. If number of students leaving the class is equal to the number of students walking in, number of students in the class are constant. But I cannot interpret that as no student is going out and no student is coming in. Field lines are going out, outwards and inwards, so the net field will be 0.
Sir, if the question setter asks, if the question setter asks the field inside, not stating whether it is E1 or E2, stating that the field inside the metal, then what will be the answer?
Net field will be 0 na yaar. Net field will be 0. Field due to Q1 will not be 0. Or field due to Q2 will not be 0.
Okay, sir. Thank you, sir.
Now, field at 2 due to Q on the outer surface. Why will it be 0? Because it is symmetrically distributed. Now they selected one more point 3. This is Z. Field at 3 due to Q at center. Somebody is saying 0. Because of Q it will be KQ by Z square. Field at 3 due to minus Q on the inner surface. Minus KQ by Z square. Sum total should be 0. Field at 3 due to Q on outer surface. KQ by Z square. For any external point, whole of the charge appears to be concentrated at center. Is the logic for the first step clear? What we have established here is all internal charges of a cavity put together is the right word, will give me field everywhere outside. All external charges put together will give me 0 field everywhere inside. All internal charges of a cavity put together will give us 0 field everywhere outside. All external charges of a cavity put together will give us 0 field everywhere. Right? Quick.
सर आपने जो E2 निकाला सर सेकंड केस के लिए सर सॉरी माइनस Q की वजह से एट द इनर सरफेस सर वो माइनस ऑफ Q वाली वैल्यू इसलिए आई क्योंकि हमने उसे कॉन्सेंट्रेटेड एट अ सेंटर पॉइंट ले लिया कि दोनों का सम 0 आना चाहिए इसलिए माइनस आई है.
You mean why you got a negative sign?
sir.
Sum of these two will be 0 only if this is negative, no yaar.
No sir, हम ऐसे बोल सकते हैं जो concentrated on charges concentrated at the center तो हम मान सकते हैं कि वो
That is the second way of interpreting. Minus q, whole of this will appear to be at the center for any external point. That means at the point 2, whole of this minus charge will appear to be at the center.
okay sir. हाँ ठीक है. Thank you sir.
Sir,
Yeah.
sir, firstly you placed Q inside the cavity and due to induction the charge minus Q like distributed on the inner surface of cavity and plus Q was distributed outside the whole sphere.
Perfect.
Is it right? Like
Perfect.
one sphere? Okay sir. Sir.
Yeah.
So like in the third case, like in the third point, sir, easily due to the plus Q outer surface. So why did we take the distance to be Z?
Given in the question, at a point 3, distance from the center is z. So for any external point, what is the field? Q and minus Q will cancel out the field here. Q and minus Q will cancel out the field here. Here the field is only because of this charge. For any external point, whole of the charge appears to be at the center.
Okay sir, thank you.
Sir, for even for the second and the third point, it's the reason that for the uniform distribution on the sphere, right? Sir, and for E2 last point, sir, it's that all external charges give 0. That is the reason, right?
Perfect. All external charges will give me 0 everywhere inside, and because I have got only one external charge, that will remain uniformly distributed.
Okay, thank you, sir.
Can I rub the board? Here, put Z equal to capital R.
said वही सीधा बैठ क्या डाउट डिस्कस कर रहा है
Please repeat the last part of the third E3.
E3, for any external point, whole of this charge appears to be at the center. For any external point, it's quite obvious now here, if you have got charge on this, and this distance is given as z. Kq by z square is the field.
Okay, sir, understood. Yes, sir, yes, sir.
I didn't understand that why the charge you placed at the center and the induced charge is equal, sir. Why not like you placed Q1 at the center and the induced charge is Q2, sir?
If that happens, will the field inside the metal be zero? If it doesn't induce equal charge, will the field inside the metal be zero?
No.
Priority is to make the field inside the field. Library से Griffiths का टेक्स्ट बुक चाहिए. Griffiths, इसको समझ में आया? Now listen. This is the cavity, and you have Q here, minus Q here, and Q here. Right? At a distance of, let me call this small r, let me call this capital R. At a distance of x, I have got capital Q here. Right? First question asks, force on Q at center due to minus Q on the inner surface. Why? Wonderful. Force on Q at center due to Q on outer surface.
Zero towards the left.
Zero, zero.
Zero is wrong. Relax. Now listen. What was the second statement of shielding? All external charges put together will give us zero field everywhere inside. The moment I bought capital Q here, this Q will not be uniformly distributed anymore. Why won't it be uniformly distributed? If small q was uniformly distributed, then it will give me zero field inside. Who will cancel out the field due to capital Q? So when capital Q has been bought here, small q will be distributed this way. Small q will not be uniform anymore. It will come to the other side, readjust itself in such a way such that it will cancel out capital Q ka field everywhere inside. I am right now not in a position to tell you the distribution of small q on the outer surface. Hence I cannot calculate the force due to this small q on this. But I can do you one favor. Force on small q due to capital Q will be K capital Q small q by x square. This will have a negative sign. This will have a negative sign. Whatever is the force on it due to capital Q will be cancelled out by this particular charge distribution. All external charges put together will give us zero field everywhere. Is the logic clear? All of you? Wait.
So the force on Q center due to minus Q inner surface will be zero because it is distributed uniformly.
Once again, repeat that question, Borivali.
So the first one, like the force on Q due to the minus Q inner surface. So that will be zero because the minus Q is distributed uniformly inside the surface, right?
Yeah.
And they will cancel each other out.
Perfect. Minus Q will be uniformly distributed. So it will give me zero field inside. So the force will be zero.
So like, will it be zero because they will cancel each other out, like the forces?
They means what? Which they?
The forces on the inner surface minus Q. And the Q, like the force between them.
He's getting confused or confusing me. Field is zero, the force is zero, no yaar. Why do you want to look at it the other way around? I am not getting your point, trust me. This minus q is uniformly distributed. It will give me zero field inside. So force on any charge inside will be zero. Isn't it? Cancellation of something I am not aware of. Halliday-Resnick gives you answers behind the textbook only for the odd numbered questions. Now in the odd numbered questions, he will give you questions where he expects you people to go wrong. You turn the page and see, then you will understand the concept. In the starting of shielding, you told me a statement which is not specified in Halliday-Resnick. Your statement was priority is to make the field zero. Induction is a consequence. Right? But the statement is not given in Halliday-Resnick. He taught you that from the exercises. In the exercises, he tells you, hypothetically, I have given minus q on the inner side of the metal. Hypothetically, first given to the inner side of the metal. Hypothetically, first given to the inner side of the metal. Why did Halliday-Resnick use the word hypothetically? Because I can never do that. If I give field minus q here, then what will happen? It will give me non-zero field inside this metal. Nature doesn't like that. So what will it do if I forcibly give minus q to the inner side? It will push it to the outer side. And once it comes to the outer side, it will be uniformly distributed so that it gives me zero. Inside there will be no charge, so this will be zero. So if ever I give minus q to the inner side of the spherical cavity, it will naturally come to the outer side of the sphere and be uniformly distributed so that the field inside the metal and the cavity will be zero. Clear? So now what he say, Halliday-Resnick says is, hypothetically first given to the inner side of the metal, then q is placed at the center. Then q is placed at the center. He is asking for the final charge distribution. He is expecting the students to fall for a trap. He is expecting the students to tell us, now that I have placed q at the center, there will be induced negative charge pulled on the inner side and positive charge pushed on the outer side. Right? And then you tell me the charge distribution on the inner side is minus 2q, charge distribution on the outer side is plus q. Turn and see the answer. He will give you 0 as the charge distributed here. Why? Induction doesn't take place. Why will induction not take place? You first gave minus q to the inner side, then you placed q. These both together are already giving me 0 inside the metal. Why will there be induction? There will be no induction taking place at all. Don't tell me minus 2q will be on the inner side and q plus q will be on the outer side. The inner side will have only minus q. Whatever charge you have given will remain as it is. Is the logic clear? Through this example, he is trying to establish to the student that the priority is to make the field 0. Once I have q and minus q placed by some external source, already the field is becoming 0. No more induction will take place. Is everybody clear about this? Yes. Quick. No induction takes place. Charge on the outer surface will be 0.
Sir?
Huh?
Sir, in the previous question when capital Q was kept outside, under what rule have you said that minus Q won't change its distribution but only plus Q?
All internal put together should give me 0 outside. If minus q redistributes itself, then it will disturb the system now here. I have q here, minus q here. Minus q was uniformly distributed. This and this together should give me 0. Now बाहर आप capital Q लिया है तो here there will be positive charge redistributed. So that this and this will give me 0. Now here this and this, if it is giving me 0, if I disturb minus q, then I should be disturbing this also. This is at the center. So this will remain uniformly distributed, only then it can cancel out. This is at the center, so this must be uniformly distributed, only then it can cancel out this particular field.
Sir,
Yeah,
So,
yeah.
sir, when you told that minus q was put there hypothetically, so then you said that it will go outside the sphere minus q and such. So how?
By chance, if you give minus q to the inner surface, you will not be able to do that, because if you give minus q, this will give me non-zero field inside the metal. So minus q will be pushed to the outer side of the metal, so that the field inside the metal will always remain zero.
So, matlab, sir, in the starting minus q was accumulated at some point only. Or sir, minus q was distributed whole inside the.
Minus q is uniformly distributed. You have given minus q uniformly to the inner side. By chance, even if you don't, you have kept minus q at one point. The moment you bring plus q, that minus q will get uniformly distributed all throughout the inner surface, so that both put together will cancel out their effect in the metal.
Yes.
so negative charge will be on both inner surface and outer surface.
Come again.
How will the field become zero if the negative charge is in the inner surface?
Yeah, minus q is negative charge, no yaar. Minus q is negative charge.
How will the field be zero?
क्या पूछ रहा है? 2 minus 2 will be 0 or 3 minus 3 will be 0. If both are of equal and opposite magnitude, minus q दिया और बाद में q रखा हुआ है यहाँ. Minus q will distribute in such a way so that it's for any external point it will appear to be at the center. So both will give me the same value, equal and opposite in the metal.
So before placing the q,
Bit louder, bit louder.
before placing the charge in the at center, you said hypothetically we will bring the negative charge on the inner surface. At that time, metal field in the metal will be zero.
Non-zero. Before I place q here, only minus q given will give me non-zero. Hence,
So if you put negative charge in the inner surface and positive charge will shift to the outer surface to make the field zero.
stand up, come close to the mic and tell me your complete doubt.
So if negative charge is inside, we need something to balance the field
Right?
to make the field zero.
Right?
Then how at that position field is zero.
Did you understand this question? Haliday-Resnick is asking you, I have placed negative charge hypothetically here. That means charge will not stay here. If I give negative charge here and leave the problem, then minus q will come to the outer surface. Why? Because this negative charge here will give me non-zero field here. Nature doesn't like that.
Yes, sir.
Right? Till here, did you understand?
Yes. Yes, sir.
Now, if I have given minus q to the inner surface and I leave the problem there, minus q will come to the outer surface to give me zero field inside the metal. But what Haliday-Resnick did is, hypothetically he gave minus q here and then he kept small q. Then he placed q at the center. Now what happens? Q and minus q will give me 0. So no further induction will take place. Why will no further induction take place? Because these both already cancelled out here. Haliday-Resnick expected the student to say that if I place q here, after giving minus q to the center, then minus q will be pulled in plus q will be pushed out. So he thought the student will fall for the trap that now there is minus 2q on the inner surface and q on the outer surface. He thought student would say minus 2q, q and plus q here. This will be wrong. Why? Priority is to make the field 0. Now minus 2q and q will be non-zero metal, non-zero field here. That will not happen. Induction doesn't happen as a primary factor. Field becoming 0 is the primary factor. Is that clear?
Yes, sir. So if we first introduce Q and then minus Q, will the positive charge on the surface disappear?
Obviously. Suppose the same example we slightly tilted this way. I tell you minus 2q is hypothetically given to the inner surface. Then q is placed at the center. Then q is placed at the center. Now what will be the final charge distribution?
Plus Q on the surface.
Then
Minus Q on the surface.
minus q will remain inside, minus q will go out. So that these both will give me 0 and this will give me 0 inside the metal. Out of the minus 2q, minus q will remain inside, minus q will go out. Both will be uniformly distributed. Both will be uniformly distributed. Is that clear? So that internal charges separately give me 0, external will separately give me 0 inside the metal. Quick.
So the minus Q first is given in the surface, that's why minus 2Q is given first, so that becomes minus Q and Q.
Verifying if I am alert or not. Minus 2q becomes minus q and minus q. Yes.
सर अगर वो 3Q होता तो अंदर Q माइनस Q रह जाता और बाहर माइनस 2Q चले जाता ना सर?
Awesome. He said if I would have given minus 3q, minus q will stay in and minus 2q will go out.
So the magnitude of charge on the outer surface is independent of the quantity of the charge. It just depends that it's uniformly distributed.
सर राइट साइड में आउटर सरफेस पे माइनस क्यू नहीं रहेगा ना सर, आउटर सरफेस पे नो चार्ज रहेगा.
क्यों?
सर
तो ये माइनस 2q का क्या करूं मैं?
सर वो गलत है. लेफ्ट साइड पे मैं बोल रहा हूँ जब अपन ने माइनस क्यू पहले डाला वो बाहर चला जाएगा आउटर सरफेस पे.
मैं अभी क्वेश्चन चेंज किया भाई साहब. अगर माइनस 2q is given to the inner side, then place hypothetically given to the inner surface, then I place q. Now for the field to be 0 here I need only minus 2q. I cannot have minus 2q. If I keep all of minus 2q here, q and minus 2q will give me non-zero field here. Nature doesn't like it. So it will release minus q to the outer surface and that will be uniformly distributed to give me 0 here.
Okay sir.
Towards the right.
Towards the right, force on this due to the field will be EQ. Force on this due to the field. Don't tell me external field don't enter inside the cavity. It does. This Q would be redistributed so that they cancel out here. If you ask me, net force on Q at the center, this is 0. Why? This external field and this will give me 0 and this is uniformly distributed, so either way it will give me 0. Say, I will add one more bit to it. What is it? Force on Q at center due to minus Q on inner surface will be 0 because this minus Q is uniformly distributed.
Yes, sir.
that will give me 0. External this and this will readjust to give me 0 inside. External this and this will readjust to give me 0 inside. Clear? All of you?
Sir, second part please, sir.
External field will give me E into Q. उसमें doubt क्या है?
Sir,
Field is E this Q.
second
First
part.
bit. Okay, relax. Now second bit. Net force on this will be 0. Why? Net force because of all external will be 0. Is that clear first?
Yes, sir, got it.
Now internal minus Q will be uniformly distributed, so it gives me 0. So net force on Q will be 0. Right? I can ask you one more question. What is the force on this due to the charge on the outer sphere? Minus EQ. Because this and this together should give me 0. So force on Q at center due to Q on outer surface will be minus EQ, because this E is giving me EQ, this will give me equivalent opposite, so that the net force on it will become 0. All external charges put together will give a 0 field everywhere. Awesome.
Sir,
Yeah.
sir, please could you explain the concept once again? I'm sorry, sir.
Which concept?
Sir, the currently question I didn't understand from the start. Please, sir.
This
I'm
one?
sorry.
There is,
Yes, sir.
there
Yes,
is
sir.
an external field E. I have kept a charge Q
Yes, sir.
inside, minus Q and Q. Right? So,
Yes, sir.
all external put together will give me 0 field here. So, this will give me EQ force on it. This will give me equal and opposite force on it. So, this and this put together will cancel out the effect here. First and fourth. The external here and the external here both put together will give me a 0 field here. Is that point clear? Once again.
Yes, sir.
Now come to the second. Net force on this will be because of external and because of this. External net is 0. This will be uniformly distributed. So obviously it will give me 0 on this. So net force on Q at the center is 0.
Yes, sir, got it.
Right?
Yes, sir, yes, sir.
Can I rub the board?
Yes, sir.
No, sir.
No, sir, no, no, no.
Because this and this should cancel out. All external should cancel out. Look at the irony. For the past 1.5 hours, we are trying to understand only one statement. What is the statement? The statement is all internal charges of the cavity will give me 0 field everywhere outside. All external charges will give me 0 field everywhere inside. This is one single statement given in Halliday Resnick. Irony, right? If we actually teach you the theory, it will be over in 1 minute. Now you look at what we are doing.
Sir,
Yeah.
sir, you said that the plus Q on the outer side will redistribute itself well, so that it transfers up the external field. Sir, but the magnitude of Q, the plus Q that can be induced is limited. Like we have a limited amount of free electrons in the metal.
But at the same time, metal by definition has unlimited free electrons. First point. We are not going to the limiting situations that a metal is completely drained of it. Second point. If I have a field this way, this will redistribute itself this way. Such that it can cancel out this effect everywhere inside. It will not be uniformly distributed. You may ask, if this is of a very large value and the Q is very small, then I will put the question this way. Suppose I did not keep any Q inside. Your point is, what if this Q is 0? What if I did not place anything inside and I switched on the field this way? Am I close to your question? Now, if there is no charge on this, how will the field inside become zero now? It will. This metal may negative charge will be pulled on this side and positive charge will be pushed on this side, such that they produce a field in the opposite direction and cancel out the external field.
So sir, there will be no internal induction, no, in this one?
No.
But even if a
If
small
ever, one second, let me answer that. By chance, if I give you any charge on the internal side, I mean SU, that minus Q will now give me non-zero field in the metal. Minus or plus, whatever charge. Nature doesn't like that. Right? Internal may there will be nothing. Internal I can disturb only by placing a charge inside. External charges cannot disturb the internal charge distribution.
Yes sir.
Somebody else was saying something in NERUL.
Sir, let's say that a small amount of charge is placed in the center, so still we need, the field is large but the small charge is still placed in the center. Still we
Doesn't
need
matter.
the field inside.
Along with this small charge, there can be new induced charges of negative and positive to cancel out the field. But the net charge of this sphere will remain only Q. Net charge will remain Q.
Okay, sir.
God knew physics before us. That's the problem. Can I rub the board?
In this question, if they ask the force on Q on the surface due to the field,
Listen to his option. Louder.
if they ask the force on the Q on the surface due to the field, it won't be QE now.
Incidentally, here it will be QE because this is a sphere. In any other body, it may not be. For any external point, gravitation, if you remember, we asked you force on this. Force on this due to this. We did the reverse and we told you force due to the ring on the sphere. What did we say? For any external point, whole of the sphere will appear to be at the center. Yeah, ki nahi? Wahi to logic apply. Right? Only if it is a sphere.
So for any other body, you won't be able
Not
to
possible, calculus will come into picture there. Charge distribution also should be known.
Sir, in this example which you have just rubbed out, sir, if we had not placed the Q in the center and we simply placed minus Q on the inner surface, hypothetically, then what would be the final configuration of the system?
Again, you place minus Q here. And you
Yes,
have
sir,
an
we didn't
extra.
place Q at this.
First point,
Yes,
the
sir.
moment I do this, this will come to the outer side and it will be redistributed uniformly in the absence of this field. Then,
Yes, sir.
then now that the field is introduced, the negative charge will redistribute itself this way. This minus Q came out. The negative charge will redistribute this way, and from the sphere there will be some more negative coming here, some more positive going here, so that the field everywhere inside is zero.
Okay, sir. Yes, sir.
Sir, for an external point, the whole of the charge appears to be concentrated at the center. So that is true only if the charge distribution is uniform, right?
Naturally, yes.
Okay.
Now listen. We can do this later. Listen. I need you people to understand one thing. Till now you stuck to two guns. Field inside the metal should be zero, is your first point. Second point, you insisted all internal charges of a cavity put together should give me zero everywhere outside. Third bench, CHEMBUR. Third bench, CHEMBUR. Kindly stand up once, introduce yourself.
Rahul Shah.
Complete name.
Rahul Shah.
Okay. What did I say just now?
I was not hearing.
I said complete name. Right. Now will you start hearing? Louder.
Yes.
Lift your hand and keep it this way. I swear to whole of the batch in CHEMBUR.
I swear whole of the batch in CHEMBUR.
That I will hear to the class hereafter.
I will hear to the class hereafter.
And will not disturb you people.
And will not disturb any.
Right. If I fail to keep this promise,
I fail to keep this promise.
I will take any punishment decided by whole of the class. He said that. They were also happy to hear that. Sit down. Now listen, I have handed over him to you people. If he disturbs you, take it for granted you can give him any punishment. You know your classmates better than me. So better listen. Now, lost track of what I was saying.
You have
Two guns.
You have 2 guns.
You were saying
Why will I have 2 guns? Kuch bhi. Listen. This is important. Till now you have stuck to 2 guns. One is field inside the metal will be 0 separately by internal and external charges. Now you told me net field should be 0. I agreed because you told me some formula called half epsilon naught E square for potential energy. And I know that nature prefers least potential energy. So I preferred 0 field. There I compromised. I believed in you. But give me one reason why all that I know is nature should make the field 0. Now why did you make internal separately 0 and external separately 0? Maybe nature preferred some 3-way complicated version of cancelling out here. Yes or no? Ultimately field should be 0. How it preferred to make it 0, why were you governing it? You insisted on the fact that all internal charges separately give me 0 and all external separately give me 0. You did not let internal of the cavity and external of a cavity interfere with each other. If you people have observed carefully. In fact, few of you had that doubt also. They said when capital Q was bought here, why isn't minus Q getting redistributed? That was what they were asking. Listen, as on date we cannot give you a mathematical proof for this. But we can give you a philosophical answer for this. Right? You will use this Griffith's textbook in your engineering first year. Just listen to this explanation. I specifically read out this passage for you people because I enjoy the language that he used. Listen. Page number 100 of Griffiths. You can Google search this. Introduction to Electrodynamics. This is the 4th edition. If I remember when 3rd edition it was not on 100th page, it was on 99th page. It's okay. The question asked is like this. Please pay attention. I will read out the complete para for you. I will not repeat it. That will be painful for me. Now according to what we have learned till now, this cavity is here, minus Q is on the inner surface, right? From a neutral metal, minus Q came in, plus Q went out, plus Q will be uniformly distributed. What will be the field here at a distance of R? What will be the field here at a distance of R? Why this Q and minus Q cancelled out here? Net field will be only because of this, KQ by
R square.
This is what we have learnt. Now listen to Griffith's language carefully. At the first glance, rather the question he asked is, an uncharted spherical conductor centered at the origin has a cavity of some weird shape carved out of it. Somewhere within the cavity is a charge Q. Charge Q also he did not place at the center of the cavity because the cavity itself is a weird shape. He wants to know the field here. Listen to the explanation carefully. At the first glance it would appear that the answer depends on the shape of the cavity and the location of the charge. But that's wrong. The answer is KQ by R square. He writes it in vector form. What is this vector form for this? KQ R by RQ. This is the magnitude of this is this. Right? No big deal. The conductor conceals from us all information concerning the nature of the cavity, revealing only the total charge it contains. Whatever charge I have got here, I have got it here. So when I am measuring the field here, I don't have any information about the shape of the cavity, nature of the cavity, orientation of the cavity, nothing. I can only tell you what is the charge inside the cavity here. Because it will be same as that of this. How can this be? Monologue, he gives the questions and answers. Well, the charge plus Q induces an opposite minus Q on the wall of the cavity, which distributes itself in such a way that its field cancels that of Q for all points exterior to the cavity. Minus Q, I repeat, opposite charge minus Q on the wall of the cavity, which distributes itself in such a way that its field cancels that of Q for all points exterior to the cavity. That's what we said, right? Since the conductor carries no net charge, this leaves plus Q to distribute itself uniformly over the surface of the sphere. It's uniform because asymmetric influence of the point charge plus Q is negated by that of the induced charge minus Q on the inner surface. Don't worry about that statement, it means the same. This and this will be cancelled out here. This must be uniform, only then it can give me 0 inside. For points outside the sphere, then the only thing that survives is Q on the outer surface uniformly distributed. Why? Because these both will cancel out here. It may occur to you that this argument is open to challenge. What is this challenge? There are actually 3 fields at work. E because of Q, E because of the induced charge, E because of the leftover charge. He is calling this field because of Q, field because of induced charge, field because of leftover charge. All we know for certain is that the sum of the 3 should be 0 inside the metal. Yet I claimed that the first 2 alone cancel out, while the third separately gives me 0 there. This is what you have been telling all of the class. All I know for sure is sum of all the 3 charges will give me 0 here. Yet I claimed that first 2 will cancel out here and the third will separately give me 0 inside the metal. Moreover, even if the first 2 cancel within the conductor, listen, moreover, even if the first 2 cancel within the conductor, who is to say that they still cancel for points outside? You told me even that. You told me Q and minus Q will not only cancel out here, they will cancel out here also. How on earth are you telling me that? They do not after all cancel for points inside the cavity. Under it doesn't cancel out. You have shown the field here. But you are telling me Q and minus Q will cancel out here. You are telling me Q and minus Q will cancel out here. They don't after all cancel out inside the cavity. I cannot give you a completely satisfactory answer at the moment, but this must be true for the least possible condition. What is it? Listen to the logic here. For the same cavity can be cut out from a sphere of a huge radius of 20 27 miles or light years or whatever. He is telling you this cavity can be cut out from a sphere of an abnormally huge radius. Can be done? If that is done, in that case, listen to the English carefully. The leftover plus Q, this is leftover, on the outer surface is simply too far away to produce a significant field. Is simply too far away to produce a significant field. They are at a far off distance. Then in that case, leftover plus Q on the outer surface is simply too far away to produce a significant field, and the other two fields would have to accomplish the cancellation by themselves. Somewhere here these two fields will have to accomplish the cancellation by themselves. So we know they can do it. So we know they means what? These two. Do what? Cancel out their field here. Then he is asking, but are we sure they choose to do it? Now we know they can do it. What? They means these both. Do what? Cancel out the field here. But are you sure they would choose to do it? Perhaps for small spheres nature prefers some complicated three-way cancellation. He puts exclamation and then he writes no. As we will see in uniqueness theorem, listen to the statement carefully. As we will see in uniqueness theorem, which will be proved mathematically for you in your engineering first year, electrostatics is very stingy with its options. Electrostatics is very stingy with its options. There is always precisely one way. No more of distributing the charge on a conductor so as to make the field inside zero. Having found a possible way, we are guaranteed no alternative exists even in principle. If I know one possible way of distributing charge, electrostatics is so stingy that that will be the only way of distributing charge for any of the systems. Which way did he found out? He said, if the sphere is of infinite radius, this Q will give me insignificant field here. Who is that in ANDHERI? If the sphere is very large, it will give me insignificant field here. So now for the net field to be zero, these both should accomplish the cancellation here. We know they can do it. Do they choose to do it? He says, uniqueness theorem insists that if there is one possible way of distributing charge, that will be the only possible way of distributing charge. Is it clear? In fact, mathematically they prove uniqueness theorem for electrostatics. There are theses where they write uniqueness theorem is all throughout the universe. No two particles will have the same set of 4 quantum numbers. No two people will be alike. No two galaxies are alike. No two planets are alike. Every planet, every galaxy, every star distribution, everything is unique. Did God have a choice in making universe this way? Today we are playing a very subtle game. We will tell you that system will work in such a way so that potential energy should be minimum. Luckily you didn't question that. I was safe. I don't have an answer for that. Why should nature prefer least potential energy? I don't have an answer for that. If we know the answer for that, we will know the mind of God. He had to create universe this way is one of the theses. That if ever a universe had to be created, it should be in a format such that the potential energy of the universe, every system will try to come to its minimum potential energy. If ever God had a choice, would he prefer to create a universe with entropy being decreasing? We don't know. If uniqueness theorem is accepted, God didn't have a choice. He has to create universe the same way. Right? Take down the diagram. I'll dictate the last 3 lines of the uniqueness theorem.
Sir, I understood that the Q and minus Q of the cavity would cancel out inside the extremely large sphere, but why would it not choose to in a small sphere?
I'll dictate the last 3 lines. Read it again. You will get the answer from that.
Sir, but sir, if it is of a weird shape, in that case, wherever there is a least radius, there the charge
Listen, if this, depending on the shape of the cavity, the charge distribution will change. If I have a sharper edge, greater will be the charge density. That's the reason why for any external point, whole of this will appear to be at this. If it is uniform, if it is a spherical distribution only, then it will be uniform. If it is non-spherical, the charge should not be uniformly distributed. It should be distributed in such a way, such that for any external point, it will be cancelled out of the field because of this. It should appear to be concentrated on this.
Okay, sir. So it will always, whatever we say, it will always cancel out.
How is there a mathematical derivation for the philosophy that electrostatics has only one way?
Third chapter,
How can it be
Griffiths.
proved mathematically?
Yes, third chapter, Griffiths. Refer to it on the net. The derivation is given. Electrostatics is very stingy with its options. Stingy, S-T-I-N-G-Y. Electrostatics is very stingy with its options. There is always precisely one way. There is always precisely one way. Put a hyphen. No more. No more. Put a hyphen. Of distributing the charge on a conductor, of distributing the charge on a conductor so as to make the field inside zero. Having found a possible way, we are guaranteed that having found a possible way, we are guaranteed that no alternative exists even in principle. No alternative exists even in principle. What is the spelling of principle that you people do?
P-I-N-C-I-P-L-E.
PL. Right? तो PL लिख दिया क्या? PAL is the principle of a college, school. PLE is a concept. When you started this concept today, you told me when Q was disturbed from the center, the minus Q will redistribute so that Q and minus Q will give me 0 everywhere outside. The external charge will remain undisturbed, only then it can give me 0 inside the metal and inside the cavity. Yes or no? This is what you told me. And the field lines from here will intercept the sphere perpendicularly because it is an equipotential surface. Yes or no? CHEMBUR, my friend will stand up once again.
Same.
Class, decide your punishment after the class and take it from him. Make sure that he spends a lot on you people. Okay? Whatever party you want, ask him, he has to give you. Sit down. Last bench people already got ready with their menu. All the best, have it. Now listen, you disturbed it from the center. You disturbed it from the center. Agreed? Question asked is, force on Q inside cavity due to Q on the outer surface.
So force on Q due to outer, na? It should be 0, na?
Perfect. This is uniformly distributed. Right? Now the $1 million question is, force on Q inside the cavity due to minus Q on the inner surface. Two options, 0, non-zero. Non-zero. Here this is not uniformly distributed. Why will it give me 0 field inside? It will not. Now third question, will the force on this due to minus Q be towards the center or away from the center? Away from center. Now, students tell me a logic that because the density of minus Q here is more, there will be an attraction. But I expect a much more matured philosophical answer here. When did you start your shielding? You told me nature will make every possible attempt to make the field 0 wherever possible. Now it has a chance. You disturbed it from the center. If this charge was at the center, inside the cavity field is non-zero. You drew the lines. Now that you disturbed it, you have an ample chance to make the field even inside the cavity, and nature will not leave the chance. It will go here, intercept the negative charge and make the field inside the cavity 0. Hence, when charge is at the center, it is unstable equilibrium. The moment you disturb it, it will continue to accelerate towards the surface. If Q is disturbed from the center, nature will not miss this opportunity of destroying this negative charge with a positive charge so that the field inside will be 0. If I push it back to the center, field in the cavity will be non-zero. Right? You have learnt one statement half the way through. Why? If you people observe today's class, we have not touched the word potential. Whole of shielding was explained using field. Now using potential also result should be the same. Next class. So then the complete statement will be over. Your class notes will be your only reference for this complete topic, because we have learnt half a statement, and any textbook will give you that statement as it is. It will not go into so many details. Your class notes will be a complete reference for this. Please keep a proper track of it. I think I couldn't take the doubts today. I was trying to keep a track of the time. 12:30 I saw the time, but then I had to complete this, so I didn't take the doubts. Next class I will take the doubts of LCV and then we will go ahead.